Everyone, this question is about integration. Find the exact area of the region R in simplified form. So this is the function sine x cos 2x, and to find the area we need to find the x-intercepts. So let's find the x-intercepts. That is when the y equals 0. So sine x cos 2x equals 0. So we use the double angle rule for cos 2a. So here we can just use the 1 minus 2 sine squared, because everything will be in terms of sine. So you multiply, and then you multiply, and then you can use a to make it simpler. So a minus 2a cubed to factor out the a, and from the two factors you have a equals 0, 1 minus 2a squared equals 0, and if 1 is moved to the right you get minus 1, divided by minus 2 you get 1 over 2, so the a is square root plus minus 1 over 2. And remember, a is sine x, so sine x is 0, x is 0, inverse sine 0 is 0, and this is rejected because obviously the x-intercepts are not 0, it's around here and here, so it's not 0, we cannot use 0. And from the plus minus root 1/2, use inverse sine, we get pi over 4 for the positive and 3 pi over 4 for the negative. Okay, so remember this is in the second quadrant. Second quadrant means we gotta do pi minus base angle, so pi minus pi over 4. Now that we have the x-intercepts, we know that we have to integrate between, this is pi over 4, this is 3 pi over 4. So since the area is under the x-axis, from the integration you will get something negative. So the area is negative the integral, because the area is supposed to be positive. So now you can, because of minus integral something, you can just use positive, but we flip the terminals. 3 pi over 4, pi over 4, you flip it, you swap, you get the integral from 3 pi over 4 to pi over 4 then. And now for the integration, we cannot integrate this directly, so we have to use the double angle formula for cos. So for the cos double angle formula we have three options. If we use this form, after we multiply by sine, we're gonna get sine cubed, and we cannot integrate sine cubed directly. If we use 1 minus 2 sine squared, again after multiplying by sine we're gonna get sine cubed. Again, we cannot integrate sine cubed directly. That's why we have to use this form. So we use 2 cos squared x minus 1. We replace cos 2x with 2 cos squared minus 1. So now we multiply sine times 2 cos squared, we get 2 cos squared sine. Sine times minus 1, we get minus sine. Now unfortunately we need a formula which is not in the MF19. So this is the integral for polynomial or the power rule, but with f of x in the base. So actually we have this rule in integration. The integral of something to the power of n times the derivative of the base is just like the usual power rule. The power is now n plus 1 divided by n plus 1. Now if we want to use this rule, we have to make sure we have the derivative of the base. So in this case, just to make it clear, for the cos squared x, let's write it down as cos x squared. So the f of x, the base is cos, and if you look at the MF19, the derivative of cos is minus sine. since there is no minus here, we can just multiply by minus and multiply by minus again, so we're not changing anything. But now this minus sine x happens to be the derivative of the base, so now we can use this rule for this guy here. Okay, so we integrate using that rule. What we get is the base, same base cos x, the new power is 2 plus 1, which is 3, divided by that new power 3. So here, if you differentiate and you check, of course you're gonna go back to the integrand. Right now the integral of minus sine here is plus cos. MF19 integration formula, you plug in the terminals pi over 4, 3 pi over 4, and subtract. Plug in pi over 4 and then 3 pi over 4 and then subtract, and you can just do everything here in a calculator and you will get the final answer in exact value 2 root 2 over 3. Alright, I'll see you again next time.